Welcome to More Learning. My name is Elijah, and I like math a lot. I've been an educator for 6 years, and I've noticed that a lot of people use their hands to count but feel insecure needing to rely on them. I think using your hands to solve a difficult problem is one of the most human things that we can do. So in this video, I'm going to show you a method to count up to 1,000 on your hands and how to use it to practice multiplication. I happen to have written a poem about this very concept, so I'm going to share that at the end of the video as a bonus. Before we jump to counting on our hands, I want to talk about the number system we use. We use something called the Hindu-Arabic numeral system. That's our classic 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Because our numeric alphabet has 10 symbols, we call this a base 10 system. So we start counting with 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know that 10 comes next, but we've run out of symbols. So what do? Well, we reset this digit back to 0, move to the left, and continue counting. Then we go to 11, 12, 13, all the way up to 19 and 20, where again, we reset this digit to 0, and then tick up the digit to the left. There are lots of counting methods that have been developed all across the world, but I want to start with how I learned to count on my fingers. While filming this video, I found out it was really awkward trying to film your palms from the first person perspective, so I've coded up this little set of counting hands to help show things step by step. I'd start with the rightmost finger and make my way across. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. How does this compare to the base 10 counting we discussed earlier? We only have one symbol, a finger, and we only have 10 of those, so we can't count any higher. Since this system only has one symbol, it's called a base 1 number system. But we can get a bit more efficient with our fingers. If our fingers aren't up, they're down. Recognizing that each finger has two possible positions means we can use our hands to count in base 2, commonly referred to as binary. Just like with our base 10 number system, we'll start on the right and make our way to the left as we add more digits. With all of our fingers down, we start at 0. Then to count up to 1, we raise our rightmost finger up. Before we can count to 2, we've run out of symbols, so we reset the thumb to down, carry over, and put our digit to the left up, just like we do going from 9 to 10 in our normal base 10 system. We can just repeat this process, raising our rightmost finger up to get to 3. Then to get to 4, we find ourselves in a situation very similar to the transition between 99 and 100. The thumb resets down, making the index reset down, making the middle finger go up. We can keep repeating this process to count higher and higher. Now, I'm explaining an entirely new number system, so if you're feeling confused, that's understandable. You can always pause, practice, and watch again. Before we move on, I want to point out some important numbers in this number system. Each single finger. In our base 10 system, we have a ones place, a tens place, a hundreds place, and a thousands place. Here, we have a finger that represents a ones, twos, fours, eights, 16s, 32s, 64s, 128s, 256, and 512's place. Each new digit allows you to count twice as high in base 2, just like each new digit allows you to count 10 times higher in base 10. When all of our fingers are up and you add their values, you'll find we count to 1,023, one less than double our left thumb's value. If you have extra fingers, you can count twice as high for each extra finger. If you're really dexterous, you can try using your toes as well. That'll be counting over 1,000,000. In the beginning of the video, I said you can use this method to practice multiplication, so let's break that down. Multiplication is just adding the same number repeatedly. In essence, we've learned to count by adding 1 over and over again, so let's try adding by 2 instead. 2 is just your index finger, so we move that from down to up. When we want to add another 2, but already have our 2's place finger up, it goes back down, and the finger to the left ticks up. It's really the same rules we've been using, just changing a different finger. Here's 4, 6, 8, 10, 12, and so on. If we count by threes, things get a little bit more interesting. 3 isn't one of our finger values, so we have to use multiple fingers to represent it. To add by 3, we're going to need to add both to the ones place and to the twos place. We're just going to combine what we did for 1 and 2, so our thumbs go up and our index too. To add the 1, the thumb goes down, and we carry over making the index go down, and carry over making the middle go up. So far we've only added to the ones place, and need to add to the twos. So we end up having our 4's finger and our 2's finger up, totaling 6. We repeat this process to get to 9, 12, 15, 18, and so on. We can use this to count through all of our times tables. The first step is figuring out how to represent that number in binary. Let's look at trying to figure out how to represent 11. First, we find the finger that's closest in value, but not bigger than our target. So for 11, that would be the right ring finger, the 8's place. Then we subtract 11 by 8, and we have 3 left over. We keep repeating this process, so we raise the 2's place finger, and then the 1's place finger, giving us a total of 11. Let's first add to the 1's place. It resets down, and we carry over, resetting the index, so we carry over again to the middle. Then add to the 2's place with no need to carry. Then add to the 8's place, resetting it down, and carry over the pinky. Now we're at 22, and we make our way to 33, 44, and so on. When I began practicing with this technique, I started putting rings on my fingers to remember which ones I needed to add. In this case, I'd put a ring on my right thumb, index, and middle finger. Practice your multiplication. First, you want to establish the binary representation of your target number. Raise the finger whose value is closest to your target number, but still smaller, and then repeat this process with what's left over. For each of those fingers, you want to flip them, and remember to carry over if you had to reset your finger down. While using this method, it's important to recognize that people have been communicating with their hands for a long time, and some of the gestures you'll use have a different meaning in another context. For example, counting to 4 is just raising your middle finger, and for obvious reasons, it's important to be mindful of those around you. With all that being said, I did promise to share a poem with you, so here is How to Count in Binary. It's always fun to learn something new. It may take time, so don't feel dumb. Each finger represents a value of 2. 1, 2, 4, all the way to 512 on the last thumb. We can add our fingers, just track what you accrue. Ring fingers up, 72 is the sum. If for liking math someone calls you a nerd, just count to 132 and give them the bird.